I'm really excited to continue the conversation we started over the past hour on energy justice in the Arctic. We have a panel now to discuss the role of emerging technology development and deployment and how that relates to Arctic energy justice. Each of the panelists have a more extensive biography online, either at the event website, again, that's energy.gov/ArcticX, or on their own webpage that you can search up. So in the interest of time, I'm going to ask each of the panelists to briefly introduce themselves and then really speak to their experience in emerging technology development and deployment and how that relates to energy justice in the Arctic. We encourage the online participants to continue putting questions for the panelists in the Zoom Q&A at any time through this. We've had some good exchange of information in the chat and in the Q&A. So if you haven't been observing that, take a look there. And in order to address time limitations and keep everybody on time for this panel, each panelist will have about 5 minutes. And so I want to jump right into that and get to the good stuff. Let's begin the panel discussion with Dr. Abraham Ellis from Sandia National Labs. Abe? Can't hear you yet.
Can you hear me okay now?
Perfect.
Excellent. Thank you so much, Matt. It is a true pleasure to be here. Thank you for the invitation. I am a member of the technical staff, have been a member of the technical staff at Sandia for a long time, since about 2012. My current role is manager of renewable energy technologies, but it turns out that this question about technology development and how it can be used to enable energy transition in remote and island communities has been a passion of mine for a long time. In fact, as another way to introduce myself, I grew up in a location in Panama without adequate access to electricity. And so for that reason, it's been a lifelong passion of mine, particularly what renewable energy brings to the table. And I'm glad that that's the track I'm in now, and myself and my team at Sandia are working diligently with DOE and many other partners, including communities, to try to address this issue. So this panel is about technology innovation and its role in energy justice. From my perspective of working in this space for over 25 years, technology certainly has made it possible to make this transition potentially with more efficiency and perhaps push the limits with respect to how much renewables, for example, we can add in places like Alaska and keep the systems running reliably. But many challenges remain still. And so that is definitely the challenge that we have to address. And energy justice is one of them, of course. So Matt asked me to include some perspectives from the work we're doing in Alaska. And we certainly will do that. There are some very unique challenges and opportunities, obviously, in Alaska related to this question of the intersection of technology and energy justice. But he also asked me to relate that work to some of other efforts that we have going on in other places like Puerto Rico and how those two things might relate to each other. So if you don't mind, I do have a couple of pictures I'd like to share. I don't know if we can put those on the screen so we can refer to them as we speak. Let's go to the next slide, if you don't mind. So as I make my remarks, I'm going to be referring to two locations here. One is the picture you see at the bottom, that's Dillingham, Alaska. We're involved in a project there as part of the Energy Transition Initiative Project, Partnership Project, or ETIP, that was mentioned in the previous panel. And the pictures over on the top right-hand side are from another project that Sandia is involved in the island of Culebra in Puerto Rico. Just to tell you a little bit about Culebra, it is, as I said, an island off the eastern coast of Puerto Rico. Both water and energy are supplied from the main island. And you might have heard that in 2017, Hurricane Maria played a trick in that community, and they were without electricity for over 1.5 years. That is the connection to the island for 1.5 years until finally that connection was made. Obviously, in the interim, they were working with diesel generators. Not a very fun time for that community. And so they are currently in transition, looking for options because the status quo right now is the same as what it was prior to Hurricane Maria. So that vulnerability remains. On the other hand, Dillingham is going through a similar transition of a different character. However, um, it does have a dependency similar to the electricity umbilical cord that um, Culebra has to the island of Puerto Rico. You can think of the same type of dependency, but in this case, in Dillingham, is fuel, as a story in many communities in Alaska, and how to deal with the resilience implications of that dependency and the cost of that is a big deal. And so both communities now are in this state of transition. How to make this transition in such a way that quality of life is improved, that we protect the environment and we support the local economy in the process, and also address historical structural challenges related to energy justice. Those are the kinds of things that we're working on right now. So 3 points I'd like to make here. One is about the fact that this is way more about technology innovation. As I said before, technology innovation does give us some more options, but we do have to, think about this as a multidimensional problem. A lot of it is in the area of obviously sociology and economy, things like that. We have to figure out ways to, as was discussed in the previous panel, challenges associated with regulatory frameworks and other things like that. And so it's much more about technologies. But let me just give you a couple of examples of how we're trying to address um, innovation, or we're trying to apply innovation to this. One of the questions that we often have in terms of technologies um, that we're trying to address as a gap is decision-making tools and frameworks. In the case of Puerto Rico, for example, in Culebra and the island in general, we're working on tools to optimize both individual microgrids and portfolios of microgrids for investment. And what we're trying to do in the work that we're doing there is including in a quantitative manner social burden and equity metrics in those technologies, in those design technologies. And so those are definitely technology innovation pieces that are not gadgets in the hardware sense, but are necessary in order to answer those questions related to energy justice. Another interesting example is in the case of Dillingham. There are some questions there, even though this project has been going on for a long time, and there's a fairly well mature idea of where it will be in the end. There are some still questions out there in the area of decision making. For example, there's questions there about how to more cost effectively capture the excess energy of a hydro project, given the fact that the resource varies and doesn't match the demand necessarily throughout the year. So that is bringing up new questions, for example, about the role of home heating and changing some of those to electrical heating potentially as a solution. So we're working on decision tools that basically don't exist right now to help stakeholders ask those questions and play what if scenarios to get to the right answer. The second point is that energy justice really does inform and sometimes changes the technology option space that we look at in terms of innovation. There's a lot in this slide there, but I'll just say in the question regarding the point about what technology the community would value, or what services that the technology enables the community would value. We have a lot of experience with that. It turns out that, for example, in the case of Puerto Rico, we have been incorporating critical infrastructure in the analysis that we do there for decision support tools, and in consultation with the communities. Their point of view has taught us that they value things, for example, like ice as a critical service or a critical product that is required in the case of a situation where there's no electricity for many days. So that is required, for example, for keeping insulin viable, and so on. And so it's important for us to account for these values that the community have, and then make an effort to include that in the technologies that we're trying to develop to support decision making. And then finally, the last point I wanted to make is that innovation really does flow both ways, and I think that's a thread that flows in this entire discussion that we're having from both panels. Is that there are real opportunities here to learn from these deployments and these experiences in Alaska and in other places. One good example of that is we're working in
Abe, I'm
communities.
sorry to interrupt you, but I want to make sure there's so many complicated things to talk about here. I know you could talk for quite a while. I want to make sure all the other panelists have plenty of time.
Yeah, let me end with that then,
Perfect.
and I look forward to the questions at the end.
Great. Thank you so much, Abe, and I'm sorry to
Thank you.
cut you short. But up next, let's
quite all right.
jump to Robin Garber-Slaght from the Cold Climate Housing Research Center of the National Renewable Energy Lab. Robin, could you share your perspectives on emerging technology deployment and energy justice?
Sure, and so thank you for letting me participate in this discussion. I've been really heartened to hear a lot of the presenters and panelists discuss, working with local communities and indigenous knowledge and local understanding of the environment, because I think that's what I was focusing on when you said, what are your thoughts on new technology? And I will say the Cold Climate Housing Research Center is in Fairbanks. So I'm based out of Alaska. And obviously we're focused on housing. And what we're looking at is, energy efficient and healthy housing. We've been working in that field for about 20 years. And when I think of emerging technology, I put it in the lens of housing. And not just housing, but home heating. If you look at typical buildings in the Arctic, 80% of the energy load in those buildings, it goes into heating. So I see a lot of focus on electricity and how can we develop electricity and, coming up with alternative methods of creating electricity. Whereas I'm always like, how do we improve heating? What can we do to lower the heating load? What can we do that can displace diesel as a heating energy? And the current kind of theory is we're going to electrify heating, and electrifying heating it's certainly possible. It's certainly possible in places that have ready access to renewable resources, but a lot of locations in Alaska don't have ready access to renewable resources. So then it's how can we lower the energy load or the heating load of a building? And that's a new building. You build a new building, you make it very energy efficient. It requires less heat. But what do you do with existing buildings? And housing across Alaska is not going anywhere. What is there has been there probably 20 years. Majority of houses have been there 20 years. They're going to be there in another 20 years. How can we improve the existing housing that is in the state? And you asked a question early on in our email exchanges about the greatest challenge that I see to emerging technology and how to address that and kind of through the lens of energy justice. And the greatest challenge I really see in emerging technology is that it's not designed for our climate and it's not designed for remote locations. And I'm gonna kind of give you some ideas, because what I see is you can't just go and deploy your emerging tech. You need to work with a community, not for, you're working with the community to use the information, the community's knowledge, the community's understanding of their situation. And to really bring new technologies, especially new technologies into remote locations, there's a workforce component, a repair component, a maintenance component that really needs to be thought through before you just deploy. And it's interesting. I'm going to share a little story. We were asked to install some low emissivity storm windows. This is a fairly new technology. it's fairly low tech. I mean, it's pretty simple. You put storm windows on a window. Most people can see how to do that. So we worked with a low-income housing authority to come up with a couple homes that we could deploy these windows on. And we did a little pre-install inspection to kind of evaluate what is their current energy use and how these windows could maybe improve that. And our inspection came back with, first of all, the existing windows were not square. You know, foundations in Alaska, frozen soils, they move. So the windows weren't square. So that made it very difficult to install these storm windows, because storm windows are going to come square. And the other problem was they were not operable. A lot of the windows were not operable. They didn't meet fire code. So before we could even deploy this new technology, we had to do this inspection. We had to go in and we had to correct pretty much these health and safety issues before we could do that technology. So if you're taking a new technology and you're going to put it out there in Alaska, I think it's not just about the technology, it's about the process. And the process needs to address existing infrastructure and workforce and poverty-related hurdles before you can even get to, oh, this fancy new shiny thing that we're going to put out there. And I worry often about new tech in especially remote areas of Alaska, because yeah, it can go out there, but it kind of becomes, especially in housing, it can become a Band-Aid and it may or may not stick. And I think in terms of at least housing and energy justice and how to improve housing across Alaska, I think there's a lot to be learned from the weatherization program, because they have a very long-standing process where they often are dealing with fairly old technology and very little funding, that they make incredible improvements in housing on a local level. And I think that would kind of be my one thought on how can we do this, is we have to have a process. And let's learn from the processes that are out there. Weatherization is the one that I certainly go to in terms of housing, but I'm sure there are other processes on how to deploy emerging tech in not just remote Alaska. I mean, in low income housing and all over the country, really. So weatherization is certainly a process countrywide. So
Well,
yeah,
thank you so much. That's really an important perspective, and I'm glad you brought that for us to the panel. I'm really excited. Next, we'll move over to Phillip from Puvernik Power, and Rod's joining us from Kungiganac. Rod, I'm hoping you can share your experience in technology deployment and energy justice with us.
I could share a few slides about our system in Kungiganac. This is a hard wind system. I'm from the native village of Kungiganac. Kungiganac is the epic name for village. I am the manager for Puvernik Power Company. We have 595 we're in Southwest Alaska. This is our location of the area. Tuntulak, Kungiganac, Quigillingak, and Kipnik have the same, pretty close to the same system. Tuntulak just got the battery bank. We've had the battery bank since 2018, and Quigillingak had the battery bank since 2017, I think. or 60. Our system is capable of doing diesels off. 95 kW Windmatic wind turbines, 50 thermal stove storage devices, ETS units, thermal stove is what we call them, which is down here. It's a 6 kilowatt thermal stove, which is capable of putting out heat of 20,000 BTUs an hour, and it's capable of heating a whole house, which is average of 1,500 square foot home in the Kong. We have a 270 kilowatt lithium ion battery capacity, 300 kilowatt ABB inverter. 2011 is pre-wind era, and this is the blue line, if you can see, which is the top one, I think. We've used a lot of fuel. Sometimes we used to use up to 100,000 gallons of diesel fuel for the power plant. And our capacity at the bulk fuel tank farm is 90,000 plus the 10,000 gallon day tank by the power plant. So some years we had to fly some fuel in. 2016 was 4 years into the for the turbines in operation. 2018 was when the battery banks were installed in January and in operation by the end of January. You can see how much fuel we've been saving. I think we saved up to 45,000 a gallon per year from there on, an average of 50,000 gallons a year. 2019 is how much fuel that we used, and 2020, which is our recently, it's the blue line. Since 2019, 2020, our wind system's been, one of our turbines been on repairs most of the years, so there's a little more fuel used and less wind. The kilowatt production from the wind diesel generators. 2011 turbine. Oops. 2012. As you can see, it go over the years. We're using more wind energy renewables over the years. 2012 was a wind diesel. Our system was a wind diesel, and 2018 to today we've been on battery banks. This is the energy summary from 2015. We displaced up to 24% fuel displacement at the power plant, or 25%, and also residential heating fuel. We displaced about 2,457 gallons for the 30 thermal stove customers during that time. $315 tons of CO2 was displaced going into the atmosphere from the power plant and residential homes during that year. 2016, 31% fuel displacement. 383 tons of CO2 was displaced from going to the atmosphere. 34,000 gallons of diesel displacement. $108,000 worth of fuel. 2017, 25%. And 2018 was when we got the battery bank installed. 44% fuel displacement. Pretty close to 50,000 gallons of fuel displaced. 537 tons of CO2. $150,000 worth of fuel savings at the power plant and residents. 2019, 43% fuel displacement. And 2020 or 32%. If you can see, we've had some issues with the turbines, but we repaired them with our local wind technicians. Since 2013 to 2020, PPC has displaced 275,000 diesel at both the power plant and ETS homes, with the average price of a diesel at $5 a gallon. Today's fuel price is $5.43 a gallon at the pump here in our fuel station. Savings is equivalent to probably by now 1.5 million probably by now. With the battery bank installed since 2018, we've been able to power the village with diesels off. The most we had diesel generators off was 6 days straight. This year we did the same thing, or 2020 we did the same thing. 6 days was the most, was the longest time period for battery diesel generators to be off. We charge the customers 10 cents per kilowatt, which is equivalent to buying diesel at $3 per gallon. So today's fuel price, they have $1.60 a gallon fuel savings. We use local wind technicians. To maintain and repair, operate our system. Cutting our downtime and keeping our system going without having to rely on outside sources. The only thing that we have difficulties is having is the weather. and modifying our wind system to Alaska conditions. We had to modify our battery bank since the temperature temperature difference was beyond its expected limitations, which is 4 plus or minus 4 degrees. I got a 6-inch duct and used black tape and put some holes on the front of the where it'll shoot air into the bottom of the battery panel, and that helps quite a bit. We were down to from a 6% temperature difference to or 6 degree temperature difference to 1 to 2 degree temperature difference.
So Rod, there's lessons learned. I'm
Lessons learned.
Perfect.
Components are meant to last, but with the local wind techs, we are able to deal with maintenance and repairs on the system. This cuts more the cost of repairs and downtime. Remote accessibility with high speed internet is critical for software upgrades and troubleshooting. Plan ahead for software upgrades. If one software is upgraded, the other software has to change too, which sometimes takes weeks or months to tweak. Request for manuals and training prior to software upgrades. On the left, you'll see some inverter breakers that went down and contactors for the wind turbines. But our guys are able to repair those. Guyana.
Thank you so much, Rod. That's a lot of information and really inspiring. So I thought it was really important to share with folks. I've never been lucky enough to come visit you in Kongiganac, but I remember going to the community of Deering and the operator went diesel off, turned off the diesel generator. And that is really an amazing feeling to hear that. So the fact that you guys have achieved that for 6 days is really cool. And I think
we have a cool video on YouTube, which is called Kongiganac, an energy success story that Amanda Bird from ASAP helped create, which is a cool video. You guys should watch it. I'll put it on chat.
perfect. Great. Well, thanks so much, Rod. That's a great perspective. And there's a lot of activity in the chat and the Q&A. I know somebody wrote, it seems like there's a lot of knowledge and insights being developed here that is highly applicable to the continental US. And that's really, I think there's so much we can learn from what you're doing. So this is fantastic. I want to make sure, just for time, that we
gets pretty challenging some days, but we're able to deal with them.
Congratulations. Yeah. Just so we have a little bit of time to wrap up this panel. Thank you so much, Rod. I want to turn to Isaac Vanderberg, the CEO of Launch Alaska. Isaac, can you share your perspectives on Arctic technology development and deployment and how it's related to energy justice?
Yeah, thanks, Matt. And really enjoyed the presentations today. And I'm calling in today from the traditional lands of the Dena'ina people, who are the past, present, future stewards of this land. So I just wanted to open aperture a little bit on Alaska. One of the things that we've skirted around or talked about today is this idea that Alaska is itself going through a real energy transition as a state. We have 5 decades of miraculous economic development thanks to oil and gas. But I think a lot of folks in Alaska are looking forward at the next 100 years and thinking through how we as a oil and gas state might be able to make this transition. And I think it's a really relevant story to not just other, oil and gas or fossil fuel states throughout the world, but just kind of the world at large. I think if we can make this energy transition as a state, there are lessons here that we can essentially export to other parts of the world. So this is a real-time, exciting story that we're living through in Alaska right now. And furthermore, I think Alaska is a really interesting place for demonstrating some of the technologies and the innovations that bring about energy transition, and doing this in a way that brings everyone along. I think if we try to make this transition as a state without thinking through the kind of social and equity and economic outcomes that we're driving for Alaskans, this transition won't happen. It'll falter. And so it's thinking through the kind of energy justice issues is not an afterthought. It is a critical path to making this transition. It's people's livelihood. It's people's inclusion in kind of wealth creation and positive social and health outcomes. And none of this gets done without people. And so it is part and parcel of everything that we're doing. In addition to some of the wonderful comments, I also just wanted to highlight that we view Alaska as this world-class place where some of the world's most exciting technology developers and innovators can partner with communities and infrastructure owners in the state. We have a program at Launch Alaska called our kind of innovation projects program, where we're basically working with communities like Kotzebue or asset owners like the Port of Alaska, or folks that own different kinds of pieces of infrastructure in the state, to help them think through how do they get to 100% diesel off in the future, or how do they fully electrify their operations in the future. And I think there's a really exciting role that Alaska has to play, where we are essentially connecting these folks who are trying to make the transition with some of these wonderful innovations that are out there. We have to do it with eyes wide open. We have to do it with full transparency and with through partnership and through having a lot of eyeballs on whatever tech that we're deploying or whatever solutions we're creating. But I do think there's a real kind of economic future for this state in being a place where we show how this gets done. In addition to this, this roadmap to 100 project that I mentioned earlier, we're super excited to be working with the Department of Energy and specifically the Arctic Energy Office and OTT, Office of Tech Transitions, on an Arctic road rally, where we're going to be demonstrating some electric vehicle technologies between Fairbanks and Deadhorse in the fall of 2022. I'm super grateful to Senator Murkowski for support of that project. And then a project that I think I'm really excited about that kind of showcases energy justice in stride is a aerospace innovation center project that we're working on at Merrill Field in Anchorage, Alaska. I think the communities of Fairview, and in particular Mountain View, are some of the most diverse communities in the country. In fact, I think in 2015, if you Google Mountain View, Anchorage, I think it was the most diverse neighborhood in the country, right ahead of Brooklyn, New York. And they're two neighborhoods that have historically been left out of some of the decisions about siting, freeways and energy infrastructure. And the project that we're working on there is looking at how can we develop a kind of innovation hub around aerospace and aviation tied to Merrill Field, but then working with the communities that are, historically underserved or underinvested communities right around Merrill Field, to think through how might a community like Fairview or Mountain View participate in energy transition? How might they build wealth? How can they get connected with some of these exciting startups and innovators that we're working with? How can a community like that own its own generation and have input on siting of things like storage? How can they be market participants? And so I think, a lot of what we're doing right now, which which I'm really excited about, is actually, standing in the community and working with folks to design their own energy transition and to be active participants in it. I was part of the group in Anchorage that created the first Solarize campaign, where we had a kind of community purchasing of rooftop solar in Airport Heights. Unfortunately, that program, while it grew to the rest of the state, it never made its way into Fairview and Mountain View because of some of the economic considerations in those communities. And so that's the exact kind of thing that we want to figure out, is how can we work with communities like Fairview and Mountain View, who are already very organized, have their own kind of innovation plans, have great ideas about their future. How can we work with them to develop some programs in tandem? So lots more to say here, but really appreciate the opportunity to talk.